Hi, my name is Michael Forrester, and I am a senior technical trainer for WebH Solutions. And I'm going to be your primary presenter today on all things relevant to Kubernetes and EKS. We're going to get started here. Let's talk about our objective today. First, let me say that our objective really is to talk about EKS, to share some understanding, some features of EKS. But just so you're aware, and I kind of joke about this. There's actually 17 ways to run containers on AWS. There's really only maybe one, maybe two, if you want to stretch the definition, ways of running Kubernetes, which Kubernetes is, of course, a container orchestrator. But there's 17 ways to run containers. But to run Kubernetes, there's really only one major way, two if you count a forthcoming feature that I'm going to talk about. So just know that while we're going to focus on EKS, and even some of its comparisons, say, to EKS and GKE, you are going to get inadvertently exposed to other container services, at least in terms of awareness. So we're going to talk a little bit just about my background, like less than 30 seconds, talk about some gifts to help you learn, some features of the Elastic Kubernetes Service, and then we're going to do the EKS GKE workshop. I'm just going to show you what a running cluster looks like, which is not like super magic, but it's good to like see it, like how, because especially for those of you who haven't manipulated Kubernetes before, it's a standard upstream Kubernetes when you run in EKS. And then I'm going to talk about the EKS workshop. So for those of you who haven't seen that before, it's kind of an unlisted public lab that AWS actually has about EKS. And then, of course, at any point in time, you can ask questions. So I reserve the right that if you ask a question and I see it in chat, I will stop and answer it. So feel free to post anything at any point in time. All welcome. Okay. All right. So I'm Michael Forrester. This is my 30 seconds or less. I basically am a senior technical trainer and teacher consultant, basically for WebH Solutions in partnership with a variety of companies, but I have definitely spent a lot of time with companies like Booz Allen and Liberty Mutual, National Guardian Life, Travelers, other companies. I actually worked last year heavily on OpenShift with Red Hat. So I was actually with them for 6 months to help them move their OpenShift installation forward. And I just recently finished a stint with ThoughtWorks as well, as far as the consulting side of things. So my background is primarily in infrastructure, never been a feature programmer, love Python, love Go, but I've pretty much touched a broad swath of technologies. I am working on my 25th year in the IT industry. So yeah, it's been doing this for a minute. I have been running Kubernetes in production since 2017, 2016, probably late 2016. And I have deployed, the largest installation I've ever done is actually an almost 49,000 pod deployment, actually, for an unnamed client that needed en masse Kubernetes hosting. So it was ridiculous, but fun. So that's my background. So I know a little bit about Kubernetes. I'm also an AWS authorized instructor, so you'll see me frequently teaching AWS classes as well. Now, if you need to find more information about me or talk to me, or if I say, hey, email me if you want to get this particular piece of information, it's just michael.forrester@webbasesolutions.com. You can get a hold of me. I'm more of a lurker on Twitter than I am a poster. But if you need to find me, it's at People Forrester. Okay, here's a little bit of collateral. So if this link, which is going to be embedded in the PDF that's sent to you, will have things like a PDF copy of this webinar that you'll also get through email. Some EKS links of interest, for example, such as latest announcements and pieces like that. Other EKS presentations that we have done or been involved in, as well as guides and reports. For example, a comparison of the top 3 AKS, EKS, and GKE providers is in here as well. So you'll see these comparisons. Now, I will forewarn you that this information is probably about 4 months old, which you might think that 4 months is not necessarily a big deal, but 4 months in Kubernetes and Docker land is like 4 years, because they really do update things frequently. So while I won't say it's out of date, just know that the numbers might be higher. meaning if they say they support 5,000 clusters, they might now support 10,000, for example. But I'll point that out as we go through information updates as well. But note that you'll have access to that. I do like to throw in recent pictures of things that are either popular or that I myself or my kids are watching. So there's a Bad Batch picture. So let's talk about what Kubernetes is. So containers are really just process virtualization. And yes, I know people will tell you, no, they're lightweight virtual machines. They don't run a kernel actually. So they're not lightweight virtual machines. You don't run a kernel inside of a container. It looks like you're running a kernel, but that's why you have to run Linux containers on top of Linux hosts. It's why you have to run Windows containers on top of Windows hosts, is that you're actually not running a kernel. You're just running the binaries inside the operating system. So containers are process virtualization. What do you do when you actually want to distribute a bunch of containers across 1,000 hosts, for example? How do you do that? Well, there used to be a couple of different answers in the industry that were really strong, like Docker Swarm, Rancher, had its own version. And then at the same time that all this was going down, Kubernetes came out and it was released by Google, and the Cloud Native Computing Foundation adopted it. And it was out of a project that Google had for a long time called Borg, or Project 7, 7 of 9, all references basically to, I believe, Voyager, if I remember correctly. And it was basically a way to isolate processes and run them across a bunch of different hosts and do auto healing, scaling, scheduling, restarting, auto expansion and auto contraction of both the host machines and the actual like container processes themselves. And this is where the evolution of Kubernetes came out. And you'll even note, by the way, if you look at the logo, that there's 7 sides to the logo. That's a nod to the original Google project name, right? Of course, there's also 7 spokes in that little wheel. Kubernetes, by the way, comes from the root word, right? That like eventually leads you to gubernatorial, Kubernetes, right? Gubernatorial, governor, right? So it actually means helmsman or captain or even leader in some contexts. And that's really what Kubernetes is it is a orchestrator for containers. Its job is to be aware of the environment that it's in and help you distribute, orchestrate, schedule, heal, and recover containers, in most cases, automatically. So it's a great product. Open source, but obviously there's paid versions of it, because like Docker Swarm, for example, supports Kubernetes. Rancher, which previously had its own orchestrator called Cattle, also supports Kubernetes. And now every single major cloud provider actually has Kubernetes on their service list. And so, here we are in 2021, and Kubernetes is actually technically close to 6 years old, 5 years old, depending on how you look at the dating, right? But it's been out and in use for at least 6 years. So whether or not you would argue it's production ready is a different thing. Now, one thing I want to note is that predominantly when we talk about Kubernetes, we're talking about Kubernetes with Linux-based hosts. There is Windows containerization, so there's Windows has been incorporated in Kubernetes, but that's at a slightly different maturity scale than Linux-based hosts, which doesn't mean it isn't going to be awesome. It just means that if you're looking at Windows-based containerization with Kubernetes, just know that it's just a little bit less mature than Linux-based containerization with Kubernetes. Okay, so in your brain, think, oh, I need something to manage my Kubernetes, my container deployments. Let me use Kubernetes. I need something to manage my container deployments at scale. Let me use Kubernetes. I need something that will give me an API-based orchestrator that will work on-premise, in cloud, or in my home. Let me use Kubernetes. So that's what Kubernetes is for, is it sits on top of an operating system, on top of either virtual or physical hardware, and its job is to manage and orchestrate containers. Good. Let me stop for a second. If there's any questions there. Okay. Let me switch to a slightly different view just to make sure that I'm offering. So this is actually from an AWS class called Running Containers on EKS, right? And when we talk about container orchestration, just to make sure the Kubernetes concept is really being driven home, the purple containerization platform that you see there on that slide, that's where Kubernetes is really sitting, right above the operating system. Now, don't get me wrong, there's projects out there in the open source world that are actually trying to make it so Kubernetes can run on bare metal, but it still requires today a Linux kernel to function. Or if you're doing Windows containerization, you'll need a Windows host. But the leaders, the formerly known as master boxes that make up the cluster, the leader boxes that make up a Kubernetes cluster, they're all on Linux. And the Kubernetes sits on top of that operating system. Notice here that the containers that are sitting on top of the containerization platform, they are all isolated from each other. Notice that they are not running an operating system. So they are actually sharing the kernel. They're being managed by the kernel. Like, for example, if it's Linux, it's called the completely fair scheduler, although you can change that if you want to. But they're using the completely fair scheduler. The containerization platform like Kubernetes is using that in the container runtime to manage the actual container. And the container itself is just a prepackaged application plus all the libraries. And that's just standard containerization. Doesn't matter whether you're using Docker or Podman or Moby or whatever, Rocket, whatever other container system you're using, it's packaged up and then it sits on top of that orchestration layer, which is the containerization platform. Now imagine, just to make sure Kubernetes is being driven home, you have to do this. You have to drive a bunch of virtualized processes, a bunch of containers across 100 boxes. You can't log in manually and do that. You could use something like an Ansible or whatever to try and orchestrate that. But then what about self-healing? What about correction? Who's going to do capacity assessment? How do we know that the box actually has the required hardware, for example? What if you want to make sure that some of your containers run on systems with GPUs on them because they've got machine learning algorithms? And what about you need other systems with fast storage? How does that happen? So when you want to handle hundreds of hosts with thousands of containers, or even thousands of hosts with tens of thousands of containers, this is where Kubernetes comes in. By the way, as of like 1.19, Kubernetes can handle a 5,000 node cluster. 5,000 nodes. That's hosts. That's not containers. That's 5,000 hosts. We're up to 1.21. I think 22 is about to come out if it hasn't already. So 1.19, we have 5,000 hosts that we could run containers on. Each host, by the way, in a cluster, I think by plain vanilla default, can handle about 100 pods, which are typically the vehicle by which we put containers in, right? Pods contain containers, if that makes any sense. So just know that each of these hosts could probably run at least 100 different containers that are all isolated. So multiply 100 times 5,000, that gives you a feel for how many containers you could run in a single cluster. By the way, most of us don't do that. We divvy our clusters up. So Kubernetes solves the problem of scheduling, placement, cloud awareness, networking, load balancing, how to manage storage, because storage is a problem. What if a container is running on one host and that host fails and the storage is local only to that host? How's the container going to retain persistent storage if storage is only localized to the host in question? Well, Kubernetes can help you solve that problem by integrating with external storage systems. Like in this case with AWS, it's EBS, right? Or EFS if you want to do network file shares, right? What about security? Kubernetes, from my perspective, is not a great multi-tenant kind of system, right? It's really better as a single tenant kind of orchestrator. But if everybody's working for the same company, right, and you've got strong security practices, one cluster could do you, right? Could actually be everything that you need. And Kubernetes also handles monitoring and logging, including like, are things up and down? Do you have enough capacity? If logs, for example, are written to standard error and standard out on the terminal by an application, Kubernetes will actually capture that and write it out to a log file. But just to say this, Kubernetes is not great at centralized logging, so it's not going to solve that problem for you. Now, so again, you got this portable, scalable, support CI/CD, API-driven container orchestration layer, which is what Kubernetes is really for. There's an incredible community, exists on all the clouds, and you can actually do things in a very declarative format and just say, look, Kubernetes, I want 5 Nginx containers along with 5, let's say security containers with them. I want to maintain persistent storage, and here's my declaration of all that. Make it happen. Figure out how to go from A to my B that I just gave you. B is my declarative format. So for example, the difference between step by step telling someone how to build a rectangle versus saying, look, I just want a black rectangle. I want it 300 by 100, and I want you to start at position point 100, 100, right? So Kubernetes can actually do imperative commands, but the declarative format are the things where Kubernetes can really sing, right? This is where it really shines. Now, just briefly, just to mention this, when you're in a cluster, containers run in pods when you're in Kubernetes. This is important for you to know because as we move into EKS, we want to make sure that everybody's familiar with the lingo. So when you run a container on Kubernetes, it's going to be in what's called a pod. A pod could have more than one container inside of it, but typically it only has one application container. Like for example, you wouldn't put an app and a database in the same pod, because what if you needed to scale the database and you didn't need to scale the app? What if the app needed to scale, which is more likely? Are you going to scale a relational database every time? I mean, again, it depends on your architecture. But like in this particular case, here's a worker node that makes up a Kubernetes cluster talking to a back-end service on another worker node that's part of the same cluster. And this is what Kubernetes does. It basically organizes access, service discovery, manages DNS internally for the cluster, manages the IP addresses and networking, and it manages the storage. In this particular case, we could actually have the web app actually talk to a service, and it would go to any of the backends. So if you are running 50 backends, instead of the web app trying to talk directly to a backend container or pod, it would actually talk to a service, and the service would direct the request to a pod, very much like load balancing. You define, by the way, pods with these kind of YAML definitions, right? So here, you've got a YAML file. So YAML is the format, right? YAML ain't a markup language, right? Or originally it was called yet another markup language, right? No, I think it was YAML ain't a markup language, but now it's called yet another markup language. And so you notice here that our Docker container, in this particular case, is Ubuntu 18.04. It's the image directive that's right under there underneath container. You could put multiple containers there. Notice that this also has persistent storage. So even though you've never seen this before, if I say, look, the image is where it's getting the application from, here are the volume mounts that are actually mounting the volumes, you can actually read this and understand it. You know, by the way, that the image is running command, it's just echoing hello world, and that it looks like they're mounting something under data/Redis. You can see that. Even though you may not have ever written any YAML in your life, this makes sense when you see it. And there's other things inside of Kubernetes like config maps and secrets, which you can also define through YAML files. You can also logically separate a cluster into different kind of security partitions called namespaces. And this isn't necessarily a Kubernetes class per se, even though it's covering EKS. But just know that it goes deeper down the rabbit hole. There's deployments that you can run through. There's different types of workload deployments. But I just want you to be aware of, like, basically this basic component is that pods are where containers run. The pods are the basic unit of deployment inside Kubernetes. Now, going back to our original presentation, that basically says Kubernetes is basically a clustered piece of software that runs on multiple hosts whose job it is to run pods that contain containers. That's its focus. How many hosts? Well, plain vanilla Kubernetes, you can run up to 5,000, right? As long as you have the right kind of primaries or masters in place, right? And that's Kubernetes. That's its function. Now, as we move into the Amazon portion of our discussion, I forewarned you. I said, look, there's 17 ways to run containers on AWS. 17. There was actually a blog post about it by a gentleman named Corey Quinn. So if you haven't seen it, just to mention this, there's actually a link inside the slide deck for it, but there's 17 ways to run containers inside of AWS. There's only really one way to run Kubernetes, which is EKS, right? So just know that there are 17 different ways to do it. Now, I forewarned you. I said, hey, you know, there's only 17 ways to run containers in AWS. But there's like one way to run Kubernetes. Be aware that it's actually, there's two ways to run Kubernetes, really. It just depends on kind of your definition. So I just want to be forthright about that. Is that you can see that there's the Elastic Kubernetes Service, which is the slightly off color one, about 4 rows down. Note that there's also EKS Anywhere, which I think is, I think it's still in preview. It might be in general availability here soon, if not already. But this basically allows you to take that box right below it, the EKS distro, and run Amazon's Kubernetes distribution on your hardware or in other cloud providers, and then have it managed as if it's running inside of AWS. So very similar to how Google did with Anthos, where you could actually run a virtual machine out in somebody else's infrastructure and have Google kind of manage that virtual machine as a workload. Amazon's done the same thing with their EKS distro. You can actually run their version of a Kubernetes on any hardware, and as long as it can talk to the Amazon API, it will have the capability to be managed by Amazon if you so choose. But we're going to dive into the Elastic Kubernetes Service. So I just want you to know the other options are there. We'll touch on EKS Anywhere, and we'll touch briefly on the EKS distro as we get to them. Okay? Oh, by the way, and we will talk about Fargate. So, all right, so let's talk about EKS. So, if Kubernetes is a container orchestrator, then EKS is a managed platform version of Kubernetes that you can run on Amazon. Now, there's actually 3 different, from my perspective, flavors of it that you can use. And one of them includes Fargate, and the other 2 are just EC2 launch types, which means you just use virtual machines underneath them. So you have the standard kind of, amazingness that you get with Kubernetes and with just running a managed platform. Because imagine now that you don't have to actually manage the underlying hardware. You also don't have to patch the underlying hardware unless you want to. Like, in other words, AWS will do it for you. You don't have to do any kind of management. And you can even go all in and go for a serverless option if you can support, like, for example, the limitations of running serverless, right? And so literally you could run EKS with no virtual machines that you manage at play. That's called, by the way, the Fargate launch type inside of EKS. So there's the Fargate launch type, and there's 2 what they call EC2 launch types. EC2, by the way, is the virtual machine service. So just note in the upper right-hand side, it says serverless option. They're talking about Fargate. Fargate only works with the Elastic Kubernetes Service or the Elastic Container Service. You might say, Michael, wait. Did you just say there's an Elastic Container Service? Why would I use the Elastic Kubernetes Service if I have an Elastic Container Service? Well, that's because you want Kubernetes. Now, if you don't want Kubernetes, go run the Elastic Container Service. It's a great service. It's older, more mature, maybe also a little bit more proprietary to AWS. But just to be frank, a lot of it, what AWS does is proprietary. So, you won't avoid vendor lock-in. It's just whether or not that you feel like they're going to be a good partner to you, right? But if you need Kubernetes, then EKS is really your only option. But just know there is an ECS, an Elastic Container Service, that also supports Fargate, which is the serverless mode, right? Now, the way that EKS runs is that you choose which way you want your hosting to happen. if you want to manage your virtual machines that make up your EKS cluster, then what will happen is that you will tell, after you create your cluster, you're going to tell EKS to create unmanaged nodes. Unmanaged nodes is an EC2 launch type where you are managing your systems, you are managing the virtual machines, you log into them, you patch them, you do the whole 9 yards, and you don't want AWS to do a whole lot on your behalf. So that's one of the EC2 launch types, is called unmanaged nodes. Now let's say you love virtual machines, you don't want to go serverless because you got some limitations, but you also don't want to like manage or patch them, you don't want to auto scale them, but you still want to be able to log in. That would be the managed node type inside of the EC2 launch type. And if we digress for a second and go take a look at the documentation for EKS, if you come down here, you can actually see that under nodes, which nodes are where all the work happens. If we look at nodes here, you've got self-managed nodes, which are unmanaged basically, and you've got managed node groups. And managed node groups are basically where you're telling Amazon, hey, I still want to have a login, but I want you to scale these things up and down, and I want you, for the most part, to manage them yourself. Like, just manage them for me, right? So just know, by the way, that when you choose your nodes in the documentation, there is very clear criteria about what you can do with managed node groups, what you can do with self-managed node groups, and what you can do with Fargate, which is the serverless mode, right? So notice, for example, if you're using Outposts or local zones, or you require Windows, your only option is self-managed nodes. Again, remember my earlier statement, Windows containerization with Kubernetes is not yet as mature as the Linux version. It's going to get there fast, but it's not yet there. So note that you have to actually run your own self-managed nodes, at least for the managed service, to even actually get Windows containers to run. Now, if you want Linux, obviously you can see that this is going to run all day long. If you need special chips, or you want to use BottleRocket, or you want to share a kernel runtime with other pods, you can actually see all the options here. But just be aware that these are the 3 different types. Managed node groups, unmanaged node groups, and Fargate are your options. And so that should speak, back to this picture, where we've got Fargate, which is the serverless option, and then we've got unmanaged and managed nodes under the EC2 option. And by the way, once you run you're running a cluster that has the leaders and the application nodes, they also just call them nodes, inside the cluster, you're ready to run whatever Kubernetes apps you want. So like, for example, what was I doing over here? Oh, that's right, I was getting hooked into my own cluster. If we go look at EKS in my console really quick, assuming that I actually, oh, that's right, I put it over here. If we go look at the cluster console, notice that I actually have an EKS cluster running. So if you look on the left-hand side, I'm under Amazon EKS under clusters, and here's my education cluster, and it's actually running 1.18 because I purposely made sure it was backer version in case I decided to update it or show a demo for an update, right? Notice that I do have ECS over here, and I also have a what could be considered an image repository, right? Or registry, right? With Amazon ECR. But I've got a cluster running. And if I click in here and I look at this cluster, I just want to point out that if I click on compute, notice that there's no particular node groups or anything else kind of configured in this particular space, which is a little unusual. But notice this is where my cluster lives. And actually, hold on, let me click around for just a second because I'm looking for something in particular. Oh, here it is. Here's my nodes, right? Notice that I've got a bunch of nodes in my cluster that are up and running. And notice I haven't necessarily put them in any particular node group, right? So I've got basically 2 T2 smalls and a T2 medium, which, by the way, are ready to scale. They're ready to auto scale whenever I decide to do that. But this is just how it looks inside the cluster. You can also see these kind of things from the command line. So if you are familiar with the command line, I can actually just list the clusters that I have. And I think I was describing a cluster earlier. I can actually get all the details of a cluster right off the command line just by using the cluster name. That includes things like its name, does it have public access, what subnets is it sitting on, is it active, are there any labels on the whole thing? And this is just to show you that currently I have 3 nodes active inside of my cluster. Now, you obviously in that particular case, I'm running the EC2 launch type because we can actually see EC2 nodes. I'm not running the Fargate launch type because in Fargate, you actually don't manage and cannot see the servers. Cool thing about Fargate, when you deploy serverless containers into EKS, it actually creates a micro virtual machine that matches the exact size, plus like 256 megs, if I remember correctly, of the container that you've asked for. What does that mean? What that means is that if you come in to Amazon EKS and you say, I'm going to create a Fargate profile for this new pod that I'm running, and this pod needs 4 processors and 2 gigs of RAM. Behind the scenes, AWS creates this like little firecracker VM that basically is the exact size of the pod that you requested, plus like 256 megs in most cases to run like a microkernel and just have some free memory for the microkernel running, right? So you're actually running, when you run in a serverless environment, you're running every single container and pod in its own independent virtual machine that Amazon is running on the back end for you. And that includes patching and all other things. Okay, so that's EKS just at a basic level. We'll go over some more features. Still looking for questions just in case they come up. But the other thing to think about is that if you want to run EKS on-premise, remember that you can actually download Amazon's EKS distribution and build your Kubernetes clusters with Amazon's really thin EKS version. To be aware, the EKS distro is actually CNCF upstream compliant with Kubernetes. So it is in alignment. It is a official distribution of Kubernetes approved by the CNCF. And this would allow you, by the way, to run the distribution in your on-premise environment, and you can actually like see EKS show up in your in your like dashboard. To take this even further, actually, I think that picture, yeah, it's for EKS distro, is that Amazon has this new service called EKS Anywhere. I kind of jokingly call it EKS Everywhere. And what you can do with this is this allows you to run that distribution not just on premise, not just in your own tooling, not just in EC2, but now you can run it everywhere and it shows up like an extension of your EKS environment in your account. So literally you can run this in GK, you could run this in Google, you could run it in Azure, you can run it on IBM Cloud, you can run it in your own on-premise, and everything's just an extension in your EKS console. Now, I want to just forewarn you, that is a little bit of marketing speak because I actually haven't touched this yet. I've talked to people who've run it, and there's been some hiccups, and it's run pretty flawlessly. But this is, I think, about to hit GA here pretty soon. And it's a great concept. And just to mention this, Google has been doing kind of a version of this for a while, but this takes this to the next level because I don't know how distributed and integrated Kubernetes has been across other people's cloud platforms in particular. So EKS Anywhere is going to be a really interesting product. Now, when you run Kubernetes and use EKS, just remember that Amazon is going to try and take hold of as much as it can to make things easy for you. So even if you don't use the serverless option, even if you don't use managed nodes and you just stick with unmanaged nodes, just know that you are no longer having to manage the control plane, which if we go back to our picture, the control plane, by the way, is where all of the like primary servers, they were formerly called masters or leaders, run. So all the components that have to manage Kubernetes, you no longer have to manage. Amazon's going to do that for you from now on. And so it really makes things simple. You get a managed control plane. You can get managed worker nodes, or again, you can go completely serverless, as mentioned before. And in addition, Amazon has both the native command line tool, and they got into partnership with a company called Weaveworks, where you can use a tool called EKS CTL to start your own Kubernetes cluster with a single command line run just from your desktop or wherever. Now, for those of you, by the way, who have been using EKS CTL, just note that a lot of these commands are also now supported by the command line tool, the AWS tool that you saw me running before. The EKS tool, especially as version 2, the AWS tool, especially as a version 2, has made great strides to be able to run everything that EKS CTL does in the tool, but it still can't do everything. So in addition to all of the orchestration, having cluster management, having node management, having a serverless option, you get all of Amazon's stacked security features around your EKS clusters. So you get, all of your security groups, all of your CloudTrail logging, all of your CloudWatch monitoring, all, if you're using, network ACLs, network NACLs, right, for security, all of your previous security considerations are in place. In addition, Amazon will capture all of the component logs for your cluster, and you can actually ask it to capture all of your logs for your pods as well, if you want to, just by putting some agents in place, some daemon sets, if you're familiar. Amazon also, just like Kubernetes, supports the native service discovery. So there's some integration, not just with native DNS, but if you actually want to use CloudMap, you can actually do that as well. This allows you, by the way, to define custom names internal to the cluster for your resources, and has these like resources change, like say pods move around and they get new names or their IP address changes, it automatically updates these maps so that your services can constantly find each other. If you have a WordPress instance that's constantly looking for its MySQL database, you can use things like service discovery to make that easier. So no matter where that database moves or where it's hosted or where it lives, the front end service can always find it. In addition, you might have heard of this cool little thing called service mesh, which is basically the ability for you to put a meshed set of proxies in front of all your applications. And you're like, Michael, that sounds really complicated. Kubernetes is already sounding a little complicated. Why would I do that? Well, the reason you would stick a proxy in front of all your applications, because now your developers don't have to necessarily write SSL TLS for all the stuff. They can actually sit in a very private, isolated network, and you can actually have the proxy handle all of the rate limiting, monitoring, caching, TLS, the basically encryption in transit, right? So when you put a service mesh on top of the pods in your cluster, you can enable all kinds of incredible features and bandwidth enhancements, if you will, for a word, than you had before. Now, Amazon has their own product for this. It's called AWS App Mesh. And they wrote this because they needed it for ECS. And it just so happened to work really well with Kubernetes. Just know that you could also run Istio or Linkerd, or Linkerd, right, depending on how you want to say it, on top of your Kubernetes cluster as well. But just know that Amazon does have App Mesh, which is a native service mesh tool written by Amazon that integrates in with all of their solutions. Okay. By the way, just a reminder, these kind of service meshes allow you to control traffic routes, do circuit breaking, retries, caching. You can actually enforce TLS SSL in products that maybe don't have the capability to actually do TLS SSL. So it can be very advantageous to run a service mesh. Other things to note is that it does actually support the native networking inside of AWS. So, just something to be aware of. And by the way, most people don't know this. Kubernetes doesn't recognize users. Not in the traditional sense. There's no user and group database inside Kubernetes. By the way, I think most of the security people just curled up and died, and I apologize. Don't worry, there's hope, right? Is that the way that Kubernetes does security is that it actually does it through certificates only. So in the subject name of the certificate, it would be like a username, for example. And the certificates have to be registered with the cluster's certificate authority. For a user, for example, to come in, or an admin, and do things inside the cluster, you have to have the certificate. Now, don't get me wrong, Kubernetes will federate with third parties, which is the recommendation. Federate with Active Directory, federate with IAM, which is AWS's authenticator, federate with ping federated or Okta. Totally fine, right? And you can actually create service accounts in AWS. But just note that traditionally, Kubernetes doesn't really support users. You can fake it out by like creating users that are based on certificates. That's basically how it works. It's kind of cool. By the way, you can do role-based access control and attribute-based access control using both the objects in Kubernetes and the certificates in question. So don't let me throw you off. Kubernetes has really strong, great security options. It just doesn't do user management in the traditional way, right? That's all. So this is an older post, so I'm actually going to go to the documentation for this. But note that Windows support has been around since 2019. That was the point of posting that whole thing there, right? Is not to show you how old it is. It's been there for a while. But if we go look at the documentation and look at Windows support, just note that when you want to use Windows support, you have to use unmanaged EC2 instances. As of today, you can't use managed EC2 instances, and you can't use the serverless option to run Windows. So there's also some other limitations, like you can't use security groups for pods, and there's some IP limitations. Most of them are fairly minor, right? Just know also is that Kubernetes, not Amazon, but Kubernetes, the development team to date has no intention of converting the leaders or the masters over to Windows. So they're not going to rewrite the components to run on Windows. So you will actually have to have a couple of Linux boxes in your cluster to run the management interfaces for Kubernetes if you decide to roll your own. With EKS, by the way, they handle that for you, right? So there are typically does require some boxes that require Linux, but if you're running like the leader portion of the cluster, AWS will handle that for you, so you don't have to mess with that. So there is strong Windows support, and it's getting better all the time. So good. Okay, we talked about serverless compute, we talked about logging, we even talked about hybrid deployments, right? Because we talked about EKS Anywhere and EKS Distro. So we've actually covered some of this stuff already. Let's see if we can actually, and we talked about logging, we talked about it being certified conformant. Cluster updates, by the way, are just literally like push button, which by the way is not how it goes when you actually have to update a cluster manually. When you update a cluster manually, you have to do all that stuff yourself, including the updating of the tools, the leader boxes, the tools that are on the host, the application nodes, and the update of the application nodes. You have to do all that yourself. With EKS, just to say this, it's so weird because it's literally just come up here and say, you know what, Michael, I'm going to run some updates for this cluster, right? That's it. And now it's going to go out there and it's actually going to run updates, and it's going to replace the boxes as needed to make sure the software is ready to go, right? And let's see. Oh yeah, it's already in progress. Good, just want to make sure. Perfect. That's it. So while we're talking, it's actually literally running an update right now. So it's just updating up to 1.19 from 1.18. So pretty cool. You can, by the way, put things like NVIDIA Tensor GPUs in there, especially if you use the right instance types. And since it is Kubernetes and it is a certified compliant Kubernetes distribution, it will work with all of the standard add-ons and plugins, barring some of the environmental stuff that AWS has, right? So like the dashboard and like, core DNS, kubeproc, all that stuff will work just fine. If you haven't seen it yet, something that's probably worth putting in your back pocket is there's a great URL called the EKS Workshop. And if you haven't seen it, this is evolving all the time, by the way. So even if you've seen it before, go take a look at it again. But this has a number of crazy labs about how to run Kubernetes on EKS, including role-based access control, how to expose a service, how to deploy a microservice using Fargate, how to encrypt secrets, how to run Windows containers for those who are interested, right? So it's a great site for that. And by the way, it goes really deep down the rabbit hole. So if you want to run like X-ray, or if you want to see like, patching your cluster or use the CIS benchmark for security, there's even stuff here for service mesh or doing canary deployments or doing machine learning with Kubeflow. There's tons of really good stuff here. So if you haven't seen the EKS workshop URL, I highly recommend that you take a look at it. And actually, I just posted a link for advanced. I actually just meant to do the workshop, but that's okay. You can get to it from there. All right. Any questions thus far about EKS before we just move on to a little bit of light comparison in the last few minutes we have left? No? Okay. All right, so here we are. Let's talk a little bit about this interesting little eye chart called, let's do a comparison. Again, this is about 4 months old. So some of these defaults have changed, but they've only gotten higher. None of them have gotten lower. I checked, right? So just know, for example, that while AWS is actually up to 1.19 as the default, they actually have 1.20 and I believe 1.21 available as well. Same for all the other providers. They've all moved up as far as versions. Just to check, have they released 1.22 yet? What is the latest version of Kubernetes? Let's see. I think that they've definitely released 1.21, right? And I think that was the last one. So they haven't yet released 1.22, but 1.21 was released in 5.12. So pretty much all of them are up to 119 and 120, and then some of them are supporting 1.21 as well. So soon. All right, so let's take a look at this just to let the numbers kind of sink in, because this is about basically AWS, Azure, and Google in that order, and plain vanilla Kubernetes. So if we take a look at like what's here, you'll notice that they all support like at least 3 versions of minor releases. Google has had their service since August of 2015, and you can kind of see that right there. Oops, didn't want to do that. And then July of 2015 is when Kubernetes hit 1.0. So this is a 6-year-old technology at this point in time. This is not brand new. This is 6 years old, which is a lifetime in the internet world. So just know that if you're kind of like, well, Kubernetes is kind of like immature, and well, for Windows containerization, that might be true, but for Linux containerization, it's been out for 6 years. It's been pretty solid. Notice that there's kind of like seamless and invisible automatic upgrade processes for both Google, Microsoft, and Windows. Notice that if you look in the upper right-hand side under Node OS, you'll see that Linux runs Amazon Linux 2. You can run Windows Server 2019. Notice they're all running Windows Server 2019 basically as the base since 1.14 and above. The other thing that I think that's of significant note is that you can actually see the container runtimes that they all support, and they pretty much all support Docker or Containerd. Now, Containerd is basically a container supervisor. There are other container runtimes, and if you look on the far right-hand side where you see Docker, Containerd, Creo, Rocket, or basically anything that implements the container runtime interface for Kubernetes, then you're good, right? So just know that if you need those container runtimes, you need to use plain vanilla Kubernetes. But by default, almost everybody supports Docker and Containerd. Now, if we go down on the comparisons a little bit, look at those control plane service level agreements. By the way, 6 or 7 months ago, they did not all have SLA financially backed agreements against the control planes. They didn't have them. They do now. So they all do. So just note that you have SLAs for your control plane to make sure it stays up. They pretty much all have NVIDIA like GPU support. And Azure is actually pay as you go as far as the cluster pricing, Whereas both Google and Amazon, if you look under pricing down here, charge you about 10 cents an hour per cluster. Like even if you don't have a node, a workload running, they're going to charge you just to have a cluster configured, right? And they're kind of doing that because there is some overhead for that, right? Now, here's some interesting, really fascinating numbers to me that I was kind of throwing at you earlier. Notice that EKS, AKS, and GKE have vastly different limitations when it comes to the number of clusters you can have in one of their data centers, right? But notice that the maximum number of nodes per cluster, is also widely different, right? So for example, you're probably going to get about 3,000 hosts, if you will, for Amazon. If you use scale sets versus availability sets, you're going to get either 1,000 or 100, right, for AKS. And then notice that GKE is just swinging for the fences, right? GKE is like, you know what? I can get you 15,000 nodes in a cluster, right? Which, by the way, is way more than the standard Kubernetes number of 5,000. Notice that there's others maxes here, like how many pods can you get per node? Just know that like plain vanilla Kubernetes, by the way, does support 100. It is configurable. If you're using, for example, OpenShift, which also runs on Amazon or Microsoft, or I believe it runs on Google as well, just note that like by default, you can get 200 pods per node if you use OpenShift. But that number is configurable on a plain vanilla Kubernetes. It's not configurable for the managed hosted providers. And there's other things here, like if you're interested in role-based access control, network policies, this is all going to be in the slide that we're going to share with you. So I'm not necessarily going to go through every single detail here, but no, like you can find this in the comparison. Obviously, you can look directly at the vendor's documentation if you need more detail. I do see a question, by the way, so Carlos, I'm going to get to it, so give me just 1 second. Note, by the way, that like pod traffic encryption and other pieces, like they're all listed here. So I just want to make sure that you're aware of the different options. I also, by the way, added in the container registry options because you probably will need a container registry in the cloud, even if it's just a pass through for your base container registry. And just some interesting pieces. One thing that stood out for me, by the way, is that Amazon does offer a free scanning service for their registry for containers. And the others actually have a paid service, which I'm not sure why they're doing that actually. And right now, Microsoft and Amazon are the only ones that have an SLA for their container registries. By the way, all of them, by the way, can be geo-redundant if necessary. All right, let me ask a question. So currently in real-world production applications, how prevalent is the use of Kubernetes to run database backends? Do you advise against doing this? So Carlos, that's a good question. My advice is that if you have been running a stateless workload for a year or more, like your team has, and you've been orchestrating them, maybe less, maybe 6 months, right? But typically a year if it's your first time running Kubernetes. If you've been running stateless workloads and you've navigated that, my recommendation is that the first thing you do is run stateless workloads for a year. Then maybe run, 6 months to a year, and then maybe run NoSQL workloads. So none of the databases you listed, right? So NoSQL workloads. So we're talking MongoDB, Elasticsearch, those kind of things. Run those on your cluster or a cluster, and then run your RDBMSs. And I say that because the NoSQL, like the non-relational databases, are a lot more forgiving when it comes to like partition loss and recovery. And your traditional RDBMSs like Oracle and MSSQL, they are not as forgiving, especially if you put them in a cluster, like a rack, for example, for Oracle. They're not necessarily as forgiving for data loss. So this is really a Kubernetes problem. It's not really a database technology problem. And if you do decide to run databases in your Kubernetes cluster, please look at operators. Operators basically give DevOps-like intelligence to your clusters. There's a great website called operatorhub.io, if I remember correctly. Did I type that right? Oh, look at that, I did. And so you can find popular databases out here like Oracle, for example. Oh, well, maybe not. That's weird. Where's Oracle? Do I have a filter on? Okay, maybe I stand corrected. Maybe this is no longer the place. Anyway, you can write your own operators, but like if you run OpenShift, for example, they have operators for this. That's weird. That really threw me off, actually. Let me try MySQL. Okay, yeah, so I guess Oracle, maybe Oracle withdrew theirs. I don't know why they would do that, but regardless, there are like operators for like MySQL and other products. I guess Oracle kind of pulled theirs off. That would make sense. Oracle tends to get proprietary sometimes. I would look at running an operator if you're going to run database workload, just to add DevOps intelligence to your cluster. But I would tell you this: that's really the thing. If you've been running for a year, year and a half, 2 years, run your database workloads. I've seen a lot of people go straight to running all of their workloads in Kubernetes, and they don't have experience doing it, and the databases really suffer. It's really a bad experience. So I would recommend, Carlos, that your team has strong experience running stateless before they run stateful workloads. Okay, good. Okay, let's wrap it up. Do note that you will get this slide usually within the next 24 hours from me. We are actually recording this as well, so you should get access to both. I teach a lot of the Kubernetes stuff, including run-throughs through the Kubernetes for like a 4-hour workshop, a 2-day workshop. There's also running containers on EKS. We also, WebH has its own native Kubernetes classes that we run that will run you through Docker and Kubernetes. So just be aware. I hope this was a good intro for you. I'm going to stop talking here for the last like 2 minutes or so and just see if anybody has any questions. But thank you for attending the workshop today. The floor is open. Questions if you have them of any type. It could be about AWS, EKS, Kubernetes, whatever you want to talk about. Okay. Well, no. Let's see. Recommendations on using OpenShift instead of plain Kubernetes. So that's a great question. So I would say this is that if you like, let me make this easier. Especially if you're an enterprise and you don't have time to kind of like futz around with figuring out Kubernetes, I would say OpenShift is a great first option. OpenShift does have a price tag associated with it, but it can be extremely valuable because not only will OpenShift solve a lot of problems for you, but Red Hat in particular, as a subdivision of IBM, will basically come in and do a lot of this stuff, like setup and other things for you, particularly. And OpenShift is so much more than just plain Kubernetes. So I think OpenShift is a great first year option, but I wouldn't stay on OpenShift after you've gotten some experience running Kubernetes in that orchestrated way. Because OpenShift gives you so much more than Kubernetes. There's like 300 open source products in OpenShift. And so if you decide to run OpenShift 4 in particular, you're going to get so many features and enhancements, you're going to get a little spoiled, but it will actually teach you how to run Kubernetes. And then you can look at year 2 and year 3 shifting off. But if you're a brand new team getting just into Kubernetes and you've got a really tight client, and you've got enterprise level SLAs, I would totally go for OpenShift. I think it's a great product. If you're in a startup and you don't have that kind of money and you got a little bit of leeway around your SLAs and you got a team that's super invested in running Kubernetes, that's a great criteria for running plain Kubernetes. But I want to be upfront about it. Running plain vanilla Kubernetes is the hardest way to run Kubernetes. Highly recommend either a managed service or a paid for offering if you're going to run it for the first time. So what would be a good education path for a beginner? That's a great question, Jeremiah. So here's one of my favorite new websites that's just came out. In addition to the EKS workshop, which I was just showing a minute ago, there's a new thing out called Kubernetes by Example. One great learning path is that Kubernetes by Example will allow you to basically go through Kubernetes fundamentals, application development. If you follow this path, understanding what Kubernetes is, what is a pod, what is a ReplicaSet, and actually like run your own cluster or just grab a cluster off of somebody else's location, or run Minikube, right? Run Minikube locally, right? And those are great options. So I would say follow this kind of path, maybe even look at Kata Coda, and you know what? Come take a class with us. Kata Coda has a website, .com/Kubernetes. I'll actually post these links in to chat so you can get them. But this is the by example, Kubernetes by example, the path. And then here is the katacoda.com path. This, by the way, allows you to run hands-on test scenarios in your browser using Kubernetes clusters. And this is actually done by O'Reilly. And you can actually just start a scenario and it will create an environment in your browser for you. So by all means, use these URLs to get started and then come take a class with us. We'll tell you. We'll help you, guide you from there if you want it, right? So that any of these URLs are a great path to start. I would probably start with Kubernetes by example, go to Kata Coda, and then go to the EKS workshop to get EKS experience. This will require you, by the way, to have your own AWS account, but you will not spend more than $5 to do every lab here, which is a ridiculous amount of value. So just know you have options. Let's see, what's the best way to start Kate's practice? Is it EKS or just a Minikube? Sujith, I would start with just a Minikube or get Kubernetes in Docker. Kind is the name of it. But Minikube or Kind is what I would do to run it locally. Run it locally first, run your workloads locally, then move to EKS, because then by the time you get to EKS, you already know Kubernetes. You'll be familiar with it already, right? So I would start there. By the way, my instance, I actually have a Minikube and a Kind cluster running on my system. The one that you saw earlier is actually an EKS cluster, but usually I have Minikube running. I think I stopped it recently. Yeah, I did. So, but Minikube is a great option. Kind is the other option. So Kind, let's see. It means Kubernetes in Docker. Kind works like Minikube, and that'll allow you to create clusters, but Kind actually works inside Docker. Minikube runs a virtual machine. So it just depends on the resources you've got available to you. Good questions. All right. Well, it is 1:04, and I want to be mindful of your time. So hopefully people have dropped if they've needed to go. Otherwise, technically, this presentation is done. Thank you for the awesome questions. Give us about 24 hours before we turn around the email and whatnot. It'll probably be sooner, but just in case. But you should see a link to the PDF and video. If you have any questions at all, reach out to me, michael.forrester@webhsolutions.com, and hopefully I'll see you at the next webinar. All right, everyone, have a great day.